Hello, my name is Brooke Foster, and along with my co-presenter, Cindy Navarrette, we will be presenting our undergraduate research project titled Analyzing the Wage Gap in the 21st Century Through the Oaxaca-Blinder Decomposition. We did our research under our faculty mentor, Dr. Asane, through the Department of Economics at the UNLV Lee Business School. The gender wage gap is defined as the difference between the median earnings of women compared to the median earnings of men. Despite the Congress-mandated Equal Pay Act of 1963, the wage gap still remains persistent in recent years. However, the subject of the existing wage gap has been dissected mainly using data from the mid-80s to the mid-90s. Our goal is to see current data and analyze the effects of time and the influence of social equality on the wage gap in our current 21st century. As shown in the bar graph below, in the year 2017, the average white male made $55.5 thousand annually, while the average woman earned only 68.5% of that amount. While a portion of the gender pay gap can be explained by differences in skills or endowments, the remaining unexplained portions are due to coefficients that suggest the presence of discrimination. For our project, we will be using data from the National Longitudinal Survey of Youth 1997 from the year 2017. The survey follows the lives of a sample set that was interviewed initially in 1997. The survey is conducted biennially, and we have utilized the data from the most recent 2017 survey. Within this dataset, there are 3,078 observations. For our equation, the dependent variable is the natural log of wage, and the independent variables we chose are education, age, Hispanic, female, union, and marital status. The variable education represents the amount of years of education that the participant has attained. The variable age represents the participant's age at the time of survey. We chose to add the following dummy variables to indicate whether or not they had a presence in our sample set. The variable Hispanic represents whether or not the participant identifies as Hispanic or not. The variable female is represented by a 1 if the participant is female and a 0 if the participant identifies as male. The variable union indicates whether or not the participant is a member of a union, and marital status simply represents whether or not the participant is married at the time of the survey. In Table 1, we have descriptive statistics that display the mean, standard deviation, minimum, and maximum values for each of our variables. As you can see depicted in Table 1, the average wage of both men and women combined is $48,498.55. And the average years of education attained is 13.5 years. In Table 2, we have a correlation matrix which describes the relationship between each of the variables. The strongest relationship indicated is the relationship between the variable wage and the variable education, which is at 0.3060, which indicates a positive yet moderate relationship.
Hello, I'm Cindy Navarrette, and I will be presenting the rest of this research paper. We have created 3 diagrams in order to see the relationship and ratio between different variables. The first diagram is a pie chart, which shows the ratio between Hispanic and non-Hispanic individuals in the dataset. With this, you can visually see the representation within the data. The second diagram is a pie chart between female and males. The values are approximately 49% and 51%. The data is relatively fair in including an accurate representation of the normal population. The last diagram is a scatter plot between annual wage and the years of education. Based on the scatter plot, we can conclude a positive moderate relationship between education and wages. In order to see the effects of each variable within the female and male model, we run 3 separate regressions. The first column displays the full model. We observe that the variables education, female, union, and marital status are statistically significant to the model, which is indicated by the 3 stars next to the coefficient. We also observe that the variables Hispanic and age are not significant in any acceptable level of alpha. The last key element to note is the R-squared, which illustrates how much the model explains the variation in wage. In this instance, the model explains 17% of the variation in the natural log of annual wages. We now look onto the female model. The only variable that is statistically significant is education. The R-squared is 0.169, which means that the model explains 16.9% of the variation in the natural log of annual wages. The last column explains the male model. The male model has three variables that are significant, those being education, union, and marital status. Upon looking at the R-squared, we confirm that the male model explains 12.7% of the variation in the natural log of annual wages. Given all this data, it's safe to say that for this dataset, the variable Hispanic is not significant. In order to create a breakdown of the wage gap, we perform the Oaxaca-Blinder decomposition, and we are left with the data in Table 4. The wage gap is a result of two components, the first being endowments, which is the difference in wages due to skill differences, and the second being coefficients, which is a result of discrimination. If you add these two values up, the sum will be the wage gap. As shown in Table 4, the value of endowments is a negative value, while the coefficient value is relatively high at 0.36. The skill differences is attempting to break down the wage gap, while the high value of coefficient is increasing the wage gap significantly. We conclude that there is still a strong presence of discrimination that leads to the wage gap being established. After analyzing all four tables along with the three diagrams we created, we conclude with a few key takeaways. The first, the variable education has a positive and significant relationship with wages. Second, there is still a very strong presence of wage gap even in today's climate. It is largely due to the discrimination that occurs against females in relation to wages. Lastly, in order to fully grasp the understanding of the wage gap, additional variables and regression outputs are needed, such as multiple regressions along different occupations and the use of newer data.